Hey everyone, and welcome. Let's talk about an invisible force that's literally all around us all the time. I mean, it's the reason our cars can stop, it's how we walk, and honestly, it can be a massive pain or an absolute lifesaver. Yep, we're diving deep into friction today, and it all kicks off with a really simple question. So let me ask you something. You've definitely been in this situation, right? You're trying to push some heavy box or a piece of furniture across the floor. That first push, oh man, it takes everything you've got. But then, once it finally starts sliding, it suddenly gets a little bit easier to keep it going. So, what's up with that? Why does that happen? Well, the answer to that question gets us right to the core of what friction is all about. Okay, so here's the secret. It's because friction isn't just one thing. Nope, it's got kind of two different faces, you could say. Two totally distinct personalities. We call them static and kinetic friction. And trust me, understanding the difference between these two is the whole game. All right, let's break it down. First up, we have static friction. I like to think of this as the grip force. It's the force that's digging in, holding an object still, and just refusing to let it move. Then, on the other side, you've got kinetic friction. This is the slide force. This is the resistance you're fighting against once the object is already moving. They might sound like they're doing the same job, but how they work is completely different. Now, here's the really cool, almost magical thing about static friction. It's smart. It's a self-adjusting force. So imagine you push on that heavy box with just a little bit of force, say 4 newtons. If the box doesn't move, it's because static friction is pushing back with exactly 4 newtons. It perfectly matches you toe-to-toe. But, and this is the key, it can only do that up to a certain point, its maximum limit. You push harder than that limit, and bang, the grip breaks. And this right here, this chart, it explains everything about our heavy box problem. See these bars? They represent something called the coefficient of friction. Now, don't let the fancy name scare you. It's just a number that tells you how sticky or grippy two surfaces are. And here's the punchline. The coefficient for static friction, our grip force, is pretty much always higher than the one for kinetic friction, our slide force. So you have to give that massive push to overcome that big static peak. But once you do and it starts moving, the resistance actually drops down. That's the easier feeling you get when it's sliding. All right, so a flat surface, we've got that down. But you know, the world isn't always flat. So what happens when we start tilting things? Let's throw a new wrinkle in here and see how friction deals with an inclined plane, where gravity suddenly wants to join the party. So check this out. Here's our new challenge problem. We've got a 6-kilogram block just sitting on a really steep 60-degree incline. I mean, just looking at it, you know that thing wants to slide right down, right? So the question is, what forces are at play here? What's holding it back and what's trying to pull it down? Okay, first things first, gravity. It never changes. It always pulls straight down towards the center of the Earth. But then you have the surface of the ramp itself, and it's pushing back. Physicists have a name for this. They call it the normal force. Just think of it as the ramp's support force. Now, here's what's super important. That force always pushes straight out, perpendicular to the surface. So on a slope like this, the normal force is actually a lot less than the block's total weight. And now for the star of our show, friction. So, since the block is naturally trying to slide down the ramp, which way do you think friction is pushing? That's right, it's pointing straight up the ramp, fighting against that slide. It's basically a tug of war. You've got a piece of gravity pulling the block down the slope, and you've got friction pulling it right back up. Whoever wins that fight determines if the block moves or not. Okay, that was pretty cool. But you know what? Let's crank up the difficulty a notch. Let's look at something even more complex. What happens when you don't have just one object, but multiple objects stacked on top of each other with friction happening between all the surfaces? Just look at the difference here. On the left, you've got your standard simple problem with one block. That means one surface and one friction force to think about. Easy enough. But look at the right. Now we have a stacked system. Suddenly we have to worry about the friction between the two blocks and the friction between the bottom block and the floor. The complexity just doubled. So let's zoom in on this particular setup. You've got block A sitting on top of block B, so right there, that's one surface where friction can happen. Then block B is sitting on the ground. Boom, that's a second surface with friction. So if we were to say pull on that bottom block, block B, we've got to figure out what's happening at both of those spots to know what the whole system is going to do. Now for this exact problem, we're given a really important clue. The coefficient of friction, remember, that's just our grippiness number, between block A and block B is 0.2. That one little number is the absolute key. It's going to tell us everything we need to know about how these two blocks are going to behave together when we start pulling on them. So here's the crucial question, the real mind bender. What's actually causing the friction on that top block, on block A? Think about it. It's the movement or even just the attempted movement of block B sliding out from underneath it. As B moves to the right, it's basically trying to drag A with it. That drag is the friction force. So if you hold block A still, like with that rope, you can feel the friction from B pulling on it. It's a perfect real-world example of action and reaction. Okay, let's switch gears completely. I want to show you a real-world example that I'm willing to bet is going to mess with your intuition a little bit. We've been talking about friction as this force that always opposes motion, that slows things down. But is that always true? Let's take a look at something as simple as riding a bike. Seriously, take a second and think about this. When you're paddling your bike and moving forward, which way is the friction from the ground pushing on your tires? Your gut instinct probably says it's pushing backward on both of them, right? I mean, it's friction, it's supposed to slow you down. But, well, the real physics here has a really surprising twist. Get this, the friction on your back wheel is actually pushing you forward. No, I'm serious. When you pedal, your chain turns the back wheel, and that wheel tries to push the road backward. So what does the road do in response? Newton's third law again. The static friction of the road pushes the wheel forward. That forward push from friction is what's actually moving you. The front wheel, on the other hand, is just being pushed along for the ride, so on that wheel, friction does what you'd expect. It pushes backward, resisting the motion. Isn't that wild? Ooh, okay, we have covered a ton of ground here, from simple boxes to crazy stacked systems, and even some really counterintuitive stuff with bicycles. So let's just take a breath and boil it all down to the key things you really need to remember. Okay, rule number 1. Static grip friction is always stronger than kinetic slide friction. That's why it's hard to get things started. 2, friction is always a contrarian. It opposes the direction an object is moving or even just the direction it wants to move. 3, when you're on a slope, gravity suddenly becomes part of the problem that friction has to solve. And maybe the biggest one of all, friction isn't always the bad guy. Sometimes, like with our bike, it's the hero of the story. It's the very force that pushes you forward. So I want to leave you with one last thought. We're so used to thinking of friction as this annoying thing that slows us down and wastes our energy. But think about the bicycle wheel. And now, think about just taking a single step. When you walk, your foot pushes the ground backward. So what do you think is pushing you forward? It's friction. Without that invisible, critical grip between your shoe and the ground, we'd all just be running in place, not going anywhere at all. Something to think about.